Welcome back to Hardware Unboxed. Today we're breaking down all the news from Nvidia and AMD's CES 2024 events in an easy to digest video. We've got 4 graphics card announcements and a whole bunch of desktop CPUs to go over, so let's get started with the official information on Nvidia's, heavily rumoured RTX 40 Super Series. As various reports have been suggesting for some time now, Nvidia has launched 3 super graphics cards at CES, all of which are coming out in January. There's the RTX 4080 Super, RTX 4070 Ti Super, yes, that is the official name, and the RTX 4070 Super. These new products give Nvidia's GeForce line a much needed overhaul in the mid-upper section of their stack. The first product to hit the market is the RTX 4070 Super, which will be available on January 17th at $600 US. This GPU is launching into the same price point as the original RTX 4070, but the 4070 isn't being discontinued. Instead, it has received an official price cut to $550, a price we first saw in the last few months of 2023. The 4070 Super is still using AD104 silicon like the 4070 and 4070 Ti, but receives a configuration that is much closer to the 4070 Ti. Relative to the 4070, the SM count has increased from 46 to 56, bringing with it 7,168 CUDA cores, just shy of the 60 SMs and 7,680 CUDA cores of the 4070 Ti. However, the memory subsystem is the same as the RTX 4070, so we're getting 12GB of GDDR6X memory on a 192-bit bus, providing 504 GB per second of bandwidth. Nvidia has a performance slide showing the difference relative to the RTX 3070 and RTX 2070 with and without frame generation, but likely also provided us with a performance claim relative to the RTX 4070. Now, this should be taken with a grain of salt given it's Nvidia's first-party benchmarking, but they are saying the 4070 Super is 15% faster on average than the 4070 and 5% slower than the 4070 Ti. While the core configuration has increased by 20%, expected performance isn't 20% higher due to the lack of change in memory bandwidth. So effectively, Nvidia are offering a new product at the same $600 price point that offers about 15% more performance, which should allow it to better compete with the Radeon RX 7800 XT, and it's this sort of price segment we saw the best competition in 2023. With the RTX 4070 now falling to $550 US, the 4070 Super also comes out looking okay, if that 15% performance uplift claim is accurate, given the Super model will be just 9% more expensive. The additional unlocked cores have seen a 10% rise in TGP though, which now sits at 220 watts. The RTX 4070 Ti Super will be available next on January 24th at $800 US in a straight replacement for the RTX 4070 Ti. The old model will be discontinued and the new model taking its place. And really, what Nvidia are offering with the 4070 Ti Super is the minimum that they should have originally offered with the 4070 Ti at this price point. The 4070 Ti Super shifts up from AD104 to AD103, which brings with it substantial memory improvements. We're now getting a 256-bit memory interface with 16GB of GDDR6X memory, up from the pathetic 12GB originally offered. This sees memory bandwidth increase by 33% as well, now sitting just shy of what the RTX 4080 offers, as the 4070 Ti Super's memory isn't quite as highly clocked. The core configuration is cut down AD103, though still higher than the original 4070 Ti on AD104, offering 66 SMs and 8,448 CUDA cores, a 10% increase. This is achieved at the same 285 watt TGP. Nvidia tells us this model should be 10% faster than the RTX 4070 Ti on average, which combined with a much needed increase in VRAM capacity seems like an okay improvement. The SM configuration is just a 13% cut down compared to the RTX 4080 with just 6% less memory bandwidth, so I'd expect this card to get reasonably close to the 4080. The big question, of course, will be how well this slots in versus the RTX 4070 Super and the Radeon RX 7900 XT from AMD. This model appears much more competitive in this price tier with AMD, although it probably will only end up around 20 to 25% faster than the 4070 Super at a 33% higher price. That's not unusual though, as typically in the graphics card market, you've had to pay anywhere from a modest to large premium to access higher tiers of performance. Then there's the RTX 4080 Super launching on January 31st at $1,000 US. This model has the least hardware changes compared to its non-Super predecessor, which is being discontinued to make way for the Super card. It's still an 8103 GPU die, this time fully unlocked with ADSMs and 10,240 CUDA cores. We're still getting 16GB of GDDR6X memory, with a small bump to frequency taking it to 23 gigabits per second. All up, Nvidia expect this card to be just 3% faster than the RTX 4080 on average, which is pretty understandable given the hardware differences. The big improvement to the RTX 4080 Super is the price. The original 4080 launched at $1,200 US, so Nvidia are now offering a slightly faster product for $200 less, a 17% discount. While not an amazing price, it's a much needed discount given the 4080 wasn't selling super well at $1,200 or even $1,100 that it eventually fell to. $1,000 makes sense in Nvidia's updated product stack, given it's offering around 20% more SMs than the 4070 Ti Super at a 25% higher price. So again, a small premium to move up to a higher tier. Previously, you were paying 50% more to get a 25% performance uplift going from the 4070 Ti to 4080 non-Super models. This also gives the 4080 Super price parity with the MSRP of AMD's RX 7900 XTX, although typically you can find the XTX for slightly below $1,000. Our testing had the 7900 XTX and 4080 pretty close for rasterization performance, with the 4080 faster in ray tracing. Back when the Radeon model was 15% cheaper, we didn't think it was an automatic buy, but was worth considering for some people. With the RTX 4080 Super at a new price that's now much closer to the XTX, that's putting a lot of pressure on AMD to lower the pricing of their flagship RDNA 3 model. You'll see reviews for all three of these models close to their respective release dates. Nvidia will be producing Founders Edition models for both the 4080 Super and 4070 Super, while the 4070 Ti Super will only be available via partner cards. When we asked about the possibility of other Super Series graphics cards for the rest of the product stack, Nvidia offered a pretty concise no comment. So they didn't exactly rule out more GPUs in the 40 series, and honestly I think some Super models are needed to fix up the 4060 series. So Nvidia's new GeForce RTX 40 Super Series cards are pretty much as expected. I see these as fixes for the lineup. All three models look much closer in specifications and pricing to where they should have been when they launched in late 2022 and early 2023. Whether or not these cards do enough to get a solid recommendation in the current market remains to be seen. They aren't worlds faster going on Nvidia's claims, but it's clear at this point that you shouldn't buy a $500 plus graphics card until these GPUs are released and have been fully benchmarked. AMD are also launching a graphics card in January, the Radeon RX 7600 XT, which is priced at $330 US. This is a very simple product that doesn't require much explanation. It's a Radeon RX 7600 with 16GB of memory, so double the VRAM, that also received a small overclock. This puts the two 7600 GPUs much closer in performance than what we saw in the previous generation between the RX 6600 and RX 6600 XT, for example, which had different core configurations. So basically, the RX 7600 XT continues to use a fully unlocked Navi 33 die with 32 compute units and 2048 stream processors. AMD are claiming a 10% higher game clock for the XT model versus non-XT, along with 16GB of GDDR6 memory at the same 18 gigabits per second on the same 128-bit bus, providing double the capacity at the same memory bandwidth. The board power rating of the card is increased from 165 watts to 190 watts to accommodate these changes, a 15% increase. AMD are claiming some surprisingly high performance improvements moving from the 7600 to 7600 XT. This chart here shows anywhere from a 7 to 40% improvement at 1080p and a 13 to 45% improvement at 1440p. The only way those larger numbers would be possible is if the VRAM capacity is the limiting factor on the 8GB model, which is certainly plausible given how many games require more than 8GB of memory for ultra-setting gaming these days. What I'm less sure about are some of those performance increases in games that aren't overly VRAM limited, like Starfield. The gains there appear to be higher than expected based on the hardware differences between the cards, so that will certainly require further benchmarking. I was also a little disappointed to see this chart from AMD, which compares performance both with and without various features enabled. No issue with the baseline numbers pitting the 7600 XT up against the RTX 4060, or for apples to apples comparisons like FSR3 enabled on both GPUs in Avatar Frontiers of Pandora or Like a Dragon Gaiden. AMD are showing the 7600 XT trading blows with the RTX 4060 in those circumstances. What is pretty misleading in my opinion are the comparisons where AMD applies their driver-based AFMF frame generation feature to beat the GeForce GPU in the output frame rate number listed in the chart. These features are not delivering equivalent output image quality, especially comparing, say, DLSS2 quality mode with no frame generation to FSR2 quality mode with AFMF frame generation. AFMF is not very good based on what I've tested so far, and absolutely does not produce image quality equivalent to other configurations in this chart. Yet by comparing in this way and treating AFMF as equivalent, AMD can show a large performance win with the new 7600 XT. It's not great when Nvidia does this, comparing RTX 40 GPUs to RTX 30 GPUs, and shows the new 40 series cards having a performance win through DLSS 3 frame generation. We've explained extensively why frame generation is not a performance enhancing technology. They are guilty of this with the Super Series data as well, although to their credit they did provide other more relevant numbers that didn't include frame generation FPS. With AMD's numbers, it's even worse because they are directly comparing Radeon with GeForce. Nvidia only compares to their own products. And on top of that, the gulf between AFMF image quality and basic upscaling or native is a lot larger than DLSS 3 frame generation image quality and basic upscaling or native. The more companies chase the highest FPS number through software features with no consideration for image quality so that they can market their graphics card as being the best in performance, the worse these comparisons get, the worse these charts get, and the more useless or misleading the information is for consumers. At least AMD did still provide native apples to apples numbers if you want a proper comparison, so I would just ignore all the AFMF and upscaling frame generation data if you want to look at the raw performance difference between these products. On a more positive note, AMD are claiming to have improved encoding image quality through rate control optimizations in the latest version of the AMF SDK. This SDK has been implemented in the latest version of Radeon software 24.1 and applies to all of H.264, HEVC, and AV1 encoding. Streaming image quality has been criticized on Radeon GPUs, particularly with H.264 for some time now, so it's good to see AMD putting work into this. Third-party apps will need to update to the latest version of the AMF SDK to get these enhancements, but I'm quite excited to see how it fares. It does look promising. The price of the 7600 XT doesn't seem amazing. The MSRP is $60 US higher versus the RX 7600 for a small clock increase and double the VRAM. Real-world pricing could be as much as $80 higher, given we have seen the 7600 fall to $250 at times, and the 7600 is hardly an amazingly priced product to begin with. I'll give some credit to AMD for making their cheapest 16GB graphics card yet and offering more VRAM in the sub $350 price tier, but it feels a bit expensive relative to the RX 7600. It's right around the price of the still available 6700 XT with 12GB of VRAM, which can be found for $320. The 6700 XT is likely to be faster, so it'll be interesting to see where it ends up in Steve's benchmarks. My gut feel though is AMD has missed an opportunity to provide extreme pressure on the RTX 4060. The 7600 non-XT and 4060 offer similar performance, so if AMD could offer a small performance win as well as double the VRAM at the same $300 price as the RTX 4060, that seems pretty compelling. At $330 though, I'm yet to be convinced. AMD also announced a range of new CPUs, including Zen 4 APUs for the AM5 platform and new processors for AM4. Let's start with the Zen 4 APUs, which are being labelled the Ryzen 8000G series. These should probably be the 7000G series, as they are from the same CPU architecture generation as other Zen 4 parts, which are Ryzen 7000, but it's not the first time AMD have bumped up the product name for APUs. They also did this with the 2000G and 3000G series. All of the new APUs are based on AMD's monolithic Hawk Point die, which is also used for Ryzen 8040 series mobile APUs, a refresh of the Phoenix die used for 7040 series mobile APUs. The top two models are straightforward. The Ryzen 7 8700G has an 8-core Zen 4 design with Radeon 780M graphics, a 12 compute unit RDNA 3 design. Up to a 5.1 GHz boost clock, 16 MB of L3 cache plus 8 MB L2 for a total of 24 MB cache. All of these APUs have a 65W TDP. The Ryzen 5 8600G then cuts this down to 6 Zen 4 CPU cores and Radeon 760M graphics, which is 8 compute units. The Ryzen 5 8500G is a little different as it uses a mixture of Zen 4 and Zen 4C. It's a 6-core model, but it's split into 2 Zen 4 cores and 4 Zen 4C cores. As a refresher, Zen 4C is a smaller core designed to be more efficient while retaining the same architecture features as full Zen 4. Along with this, there's Radeon 740M graphics, providing 4 compute units of RDNA 3. There's also a further cut down Ryzen 3 8300G, but this will only be available in pre-built systems. All of these APUs will be available on January 31st, the 8700G priced at $330 US, the 8600G at $230 US, and the 8500G at $180 US. The 8500G will therefore end up matching the price of the Ryzen 5 7500F, the 8600G will match the price of the 7600, and the Ryzen 7 8700G will match the price of the Ryzen 7 7700. That's looking at MSRPs of course, although current retail pricing is pretty close to the MSRP for these parts. As we discussed in our recent podcast episode, these APUs are going to be pretty niche products. With half the L3 cache of the regular Zen 4 desktop CPUs in the Raphael series, along with lower boost frequencies, the 8000G APUs will likely be slower for gaming when paired with discrete graphics. So anyone wanting to build a system with discrete graphics in mind will probably be better off with other Zen 4 parts, either the Ryzen 5 7600 at the same price as the 8600G, or the 7800X3D, which is $70 more expensive than the 8700G right now. The integrated RDNA 3 GPU in these products is going to be quite a bit faster than the 2 compute units offered with Raphael CPUs, but still only sufficient for low quality setting gaming at low resolutions. In this chart, for example, AMD are only claiming 60 FPS in modern titles using 1080p low settings when paired with AFMF frame generation. I can't imagine the experience in Alan Wake 2 with a native frame rate of 26 FPS boosted to 62 FPS through driver-based frame generation will be any good at all. More realistic use cases for these products are games like Dota 2, League of Legends, and older games like Grand Theft Auto 5. The big question mark with this sort of APU and why it may relegate them to niche use cases is whether or not they are a better buy than a regular CPU paired with a low-end discrete GPU. With previous APUs, we've typically found the CPU plus discrete GPU pairing to be the better choice, but we'll have to wait and see where the 8000G series ends up in performance and value. With that said, it's good to see AMD launching new APUs at the same price as the equivalent CPU model, which I think is a better strategy than what we've seen in the past. The previous APU line, the 5000G series, had the 5700G at $360 and the 5600G at $260. That was a $60 premium for these APUs over the 5700X and 5600 respectively. Price parity makes a lot more sense. It means buyers will be tossing up whether to get likely faster CPU performance from the non-APU models or the integrated graphics capabilities of the APU G-series models, instead of also needing to factor price into that equation and typically a premium for the iGPU functionality. AMD are also launching 4 new AM4 processors, which can be summarized as follows. The Ryzen 7 5700X3D is a 5800X3D with a 400 MHz lower clock speed. So same 8-core Zen 3 design, same 96 MB L3 cache, same 105W TDP, just with a 9% lower boost frequency at 4.1 GHz. It'll be priced at $250 US, which could be a really compelling buy for AM4 owners, given the 5800X3D has only briefly been seen below $300 US across the last 12 months. Its typical price is in the $320 to $350 US range, making the 5700X3D over 20% cheaper. The Ryzen 5 5700 is a 5700G APU with the integrated graphics part disabled. This was previously released as an OEM only part but will now be available as a boxed processor. Same 8-core Zen 3 CPU design with 16 MB of L3 cache and PCIe 3.0 capabilities, same 4.6 GHz boost clock and 65W TDP, just no iGPU. It'll be priced at $175 US, so $25 less than the Ryzen 7 5700X or 5700G. It'll be interesting to to see the gaming performance of that part given its reduced L3 cache capacity relative to the 5700X and Ryzen 5 5600, the latter of which is just $150 these days. Will it be worth getting an extra 2 cores for $25 more relative to the 5600, even if that means sacrificing L3 cache? Not sure. It would depend on the workload and may not be the best choice for gaming. There's 2 new APUs as well. The Ryzen 5 5600 GT is a 5600G with a 200 MHz higher boost clock and 300 MHz lower base clock. And the 5500 GT is a 5600G with the same boost clock, just with a 300 MHz lower base clock. Both have the integrated graphics enabled and are designed for entry-level systems, the 5600 GT priced at $140 and the 5500 GT at $125 US. All of these new processors, the 8000G series and the new AM4 processors, will be available on January 31st. It seems like Steve will have an exceptionally busy February reviewing processors. Doubly so because Intel are just about to announce more 14th gen CPUs as well, if the rumors are to be believed. And that does it for Nvidia and AMD's CES news for 2024. 4 new graphics cards to get excited about, all launching in January, along with a new range of CPUs as well. That means lots of reviews to look forward to. Make sure you're subscribed to Hardware Unboxed so you don't miss our in-depth testing, which I think will be coming up pretty soon with the 4070 Super set to be released in the middle of January. Anyway, that's it for this one. If you do appreciate our independent analysis, reviews, testing, all that sort of thing, we do have our Patreon and Flipplane accounts. Links to those are in the description below. You can sign up, gain some cool benefits like our monthly live streams, BTS videos, behind the scenes chat, and more. So thanks for watching, and I'll catch you in the next one.